Okay, we're in the final problem of this unit. This is an interesting one because it's hard to kind of get enough information to get started, even though it looks like there's a lot. There's stuff hidden in the words as opposed to, just giving numbers. So we have Mr. Chung and Mr. Wills. They're going to see a Blue Jays game down in the city, and they're both standing in front of CN Tower. Now, Mr. Wills, he's facing east. I'll just zoom in here. And his angle of elevation to the top of the tower when he looks up is 68 degrees. So if this is Mr. Wills and he looks up to the top, that's 68 degrees. Okay, Mr. Chung, he's staring at the CN Tower as well. He looks to the top and his angle of elevation is 62 degrees. We also know that they are 367.74 meters from each other. And the question asks how tall, let me zoom out here, is the CN Tower given this information. Now, I guess I'll put it in, but just put in this kind of broken line here. Call this H. And that's what we want to figure out. And we can assume that the CN Tower makes a right angle with the ground, so I'll kind of put that in there. And Mr. Wills, kind of triangle as well. And, it's kind of like, well, how do we solve for this? If I wanted to use SOHCAHTOA with H and 62, well, I don't have any sides, well, not the H. I don't have another angle. I don't have enough information. I only have that 62. And similarly, if I wanted to solve with Mr. Wills over here, I only have the 68. I don't have this side. I don't have this side. Obviously, I can figure out the other angle in both cases, but I don't have another side. And again, I'm stuck. Sine law doesn't apply here because it is a right angle triangle, so it makes no sense in trying to use that. But I do have this information here on the bottom. Okay, think of this triangle as kind of like lying on the floor. Okay, and all you know about it is that it is 367.74 meters between Mr. Wills and Mr. Chung. Now, when you look at this, let me just take that triangle on the bottom, kind of out of the picture. I'm going to try doing that. I'm going to trace over it with an orange. So I'll go over here, I'll go over here, and I'll go over here. When I take that triangle out of this context, let me just kind of drag it out here. Remove that red line. Okay, what I have is 367.74, and I'm going to drop the meters. Again, this is my triangle. It was here. I'm just taking it out so I can see it a bit more clearly. That 62 degrees does not figure in here because this side, okay, is, it's sticking out. It's sticking above the ground, okay? Just like this side here is sticking above the ground as well, okay? So the angles don't figure out in this scenario. In other words, I have a triangle. I don't know if it's right on face value. All I know is that one side is 367.74. It looks like it could be an obtuse triangle. I don't know. Here's where we have to go back to the information of the question. Okay, when I said the words, I literally meant, look at the direction he's facing, east. Look at the direction Mr. Chung is facing, south. So if Mr. Wills is facing, I'll go back to my orange here. If he's facing east, let's say this way is east. Okay, and Mr. Chung is facing south, which is this way here. Well, we know that these directions intersect with each other at 90 degrees. So in fact, this triangle, even though I've drawn it this way, is a 90-degree triangle just sitting on the ground. That's going to help us. Okay, I'm going to take out these directions for now. I don't want to, maybe I'll leave that one there because we do know now that it's 90 degrees. I still don't have enough information to, well, I have enough. It's just I don't know where to go from here. Like, how do I solve this question? Well, I'm going to try to connect the ideas or the information here, sorry, in this question in such a way that, I can start using these relationships to solve for h. And to do that, I'll have to introduce a variable. I'm going to introduce an x over here. Let me get back to my black marker. An x over here. I'm going to put a y over here. And notice that the x's and the y's, they relate to both the triangle on the ground and the triangles on the sides. Okay? So what can we say about the ground triangle? And I'll do that over here. Well, we know that by Pythagorean theorem, I get this. Okay? Keep in mind, there are 1, 2, 3 variables, and maybe it hasn't been stressed enough, but the number of variables you have usually dictates the number of equations you want to have in order to solve. If you now look at this triangle here on the side, I can relate x and h and 62. How? Well, let's do this. Tan of 62 degrees is equal to h over x. Similarly, tan of 68 degrees is equal to h over y. 3 equations, 3 unknowns. I think I'm making progress here because I see an idea. I'm going to rearrange this equation for x. Namely, x is going to be h over tan of 62 degrees. And I'm not solving yet for tan 62. Okay, I don't want to start carrying decimals around and getting all having to write things out even with his iPad, which is a lot easier. I want to avoid that. Keep it nice and neat. Then I have tan of 68 for y. Well, I'm going to substitute both these values into this equation here, and it ends up that I get just one equation with the value of, whoa, that's not what I wanted, with a variable value of h. Okay, let me copy this. There we go, there's my y. So let me take this here. No, I don't want to do that. Let's do this. Okay, and what I'm going to do is I'm going to take out that x and replace it with this guy. I'm squaring that whole thing, by the way, so that has to all be in square. Put that out here. And similarly with the y, I'm going to have to make a bit more space. I'm going to take out that y and replace it with this y, and I'm going to square it as well. So I'll just put that there. This plus goes in the middle, and everything is in brackets. And now this guy can just scoot him in, and voila. We have now one equation, one unknown. I know it's a little bit messy, but it is still one unknown, and we can solve. So let's get to it. I'm going to now bring that square in. So I'm going to get h squared over tan of 62 squared, whatever that is, plus h squared over tan of 68 degrees, whatever, square, curly brackets, squared, equals 135, 232.7076. Again, I've just done this before, or you can look at the notes. And let's now do the calculation. So over here, I'm going to square this and divide it into 1. Okay? Because remember, you're looking at, if you want to think of this in a different way, I like to think of this fraction here as 1 over, let me copy it, this, okay, times h squared. Okay, similarly, this guy here, same thing. Okay, I'm going to maybe take this paste it over here. Take the h squared out to the side and put a 1 at the top, and that's a times, equals all that stuff. Okay, when you do the math, I get, I'm going to get some decimals now, 0.2827 h squared. Sorry, that's for the other one. So let me move that over here. And then for this one, I get 0.1632. So that's 0.1632 plus, and that's h squared, equals whatever that number, again, I don't want to copy it. Then I'm going to add these together, and that gives me 0.4459 h squared equals, again, that big fancy number. And finally, I'm going to get h squared. Well, not finally, almost. Remember, I'm dividing both sides by 0.4459. It's going to give me 303,280.3489. Okay. And finally, I take the square root of that guy. I'll do it here. And that gives me a value of 550.7 meters. Whew, a lot of work, a lot of calculation. Again, I used the notes to speed up the process, but I strongly encourage you to do this on your own calculator. But all of this finally gives us the height of our pyramid, our CN Tower, which is 550. And I don't really know if that's true, by the way. It's pretty high, but I don't know what the actual height of the CN Tower is. But according to this question, it's 550 meters. Sounds pretty reasonable. Again, think of a 400-meter track with an extra 150 meters, unraveled and, pointed straight up. Yeah, the CN Tower is pretty tall. Anyway, so there's this problem. Again, the hardest part, I think, is setting up these equations. But once you have that, okay, once you've understood it, the rest is just straightforward calculation, which is always good practice.